Hello, and welcome to a digital lecture for Salt Lake Community College. This lecture will cover section 3.4 for Introduction to Statistics, confidence intervals. There are only a few definitions in this section that we would like to be comfortable with. The first is the definition of a confidence interval. A confidence interval gives a plausible range of values for the population parameter of interest. This can be visualized as an interval of values that would contain the population parameter. And a sampling distribution, this will give all the values of your point estimate, which can be computed from all possible samples of the same size from the population of interest. Let's look at how we would construct a 95% confidence interval to get started. When the sampling distribution of the point estimate can be reasonably modeled as normal, the point estimate we observe will be within 1.96 standard errors of the true value of interest about 95% of the time. Thus, a 95% confidence interval for such a point estimate can be constructed by looking at your point estimate plus or minus 1.96 standard errors. So visually, if your point estimate is the center of your confidence interval, we can add 1.96 standard errors to find the upper boundary of our confidence interval and subtract 1.96 standard errors to find the lower boundary of our confidence interval. We could then be 95% confident that this interval captures the true value. Now, I did not explain where the 1.96 came from yet. We will look at this soon. This method for constructing the 95% confidence interval can be now generalized to construct a confidence interval for any confidence level. If the point estimate follows the normal model with a standard error, SE, then a confidence interval for the population parameter can be constructed by looking at your point estimate plus or minus a critical value times your standard error, where Z, your critical value, will correspond to your desired level of confidence. Now, if your confidence interval is for the population proportion, then the product of your critical value times your standard error is referred to as your margin of error. So in your formula for your confidence interval, this is the margin of error. And if we're trying to construct a confidence interval for the proportion, then your point estimate is going to be p hat. We would add the margin of error to find the upper boundary of your confidence interval. Subtract your margin of error to find the lower boundary of your confidence interval. So notice that your point estimate will always be in the center of your interval, and then it'll be symmetric. The amount that you go up or down will be the same. Consider the following tips when writing interpretations of your confidence interval. A correct confidence interval interpretation must include a statement about the level of confidence in the interval and a description of the parameter we are attempting to capture. Your confidence interval interpretations should not include any statement about probability or chance, any indication of uncertainty in the parameter value, or any discussion of capturing the sample statistic or the point estimate, individual observations, or the proportion of observations. It's also important to note what the confidence level refers to. Our level of confidence refers to our confidence in the method we use to get the interval, not in the lower and upper bounds of any particular interval. If we used the same method to compute many different intervals, the confidence level tells us the approximate percentage of those intervals that would capture the parameter. Consider what 95% confidence intervals for a mean IQ score would look like. And consider that the true mean IQ score is 100. If we constructed 100 confidence intervals, then the 95% confidence level would tell us that 95 of these intervals would contain the true mean IQ score, and 5 of them would not. So notice there are a couple of these confidence intervals that do not capture the parameter of interest, but 95% of them do. So our confidence level refers to the method we are using, not the actual interval, or not the values in our interval. Let's look at an example. In January of 2011, the Marist poll interviewed 1,018 American adults and found that 672 of them thought elderly drivers should be required to retake their road test when they reached 65 years of age. Using a 95% confidence level, a confidence interval was constructed. Write an appropriate interpretation for the confidence interval. Now, I would like to ask you to pause the video for a moment and think about what your confidence interval interpretation should look like. After you've thought about it, come back, unpause the video, and we'll see how you did. I'll see you in a moment. Okay. I hope you paused the video for a moment and thought about what your confidence interval interpretation should look like. There are many different ways we could, of course, word this. Here is one interpretation of how you can write this. We are 95% confident that the interval between 63.1% and 68.9% captures the true proportion of American adults that think elderly drivers should be required to retake their road test when they reach 65 years of age. Notice that this confidence interval does include a statement about the level of confidence. And it also includes a description of the parameter we are attempting to capture. Okay, this about covers all the definitions that we have for section 3.4. If you have further questions, be sure to review the example videos that follow or ask your instructor.